Adrok have been developing a new sulfide targeting tool called the Weighted Sulphide Correlation Criteria, or WSCC for short, that can be used for undercover mineral exploration, particularly for massive and disseminated sulfides for many different metals like gold, copper, lead and zinc. The motivation for creating this tool comes from discussions with clients on creating a technique that can pinpoint at exactly what depth sulfides exist beneath the Earth's surface. The energy transition has a big part to play, with many metals and minerals, for example copper, increasing in demand in order to support the infrastructure for renewable energy and electric vehicles. With a progressive decrease in Tier 1 deposit discoveries and a projected increase in demand for metals and minerals, an increase in new resource discovery and the development of new exploration technology and techniques will be required to keep the metal supply on track with the increased demand. Hence, Adrok's new WSCC tool. Adrok has been using a technology called atomic dielectric resonance, or ADR, to collect and record data over mineral deposits for well over 10 years. We transmit a pulsed broadband of radio waves between 1 to 70 MHz frequency into the ground using a transmitting control unit and antenna, which is then captured and recorded by a receiving control unit and antenna. The signal or energy that we pulse into the ground is reflected back to the surface at boundaries where there is a change in dielectric permittivity. This works very well for sulfides, as the dielectric permittivity is very high relative to the rocks in which they are contained, for example granites and sandstones. This forms a unique geophysical fingerprint that can be detected by ADR technology. The equipment is also small and portable, and able to be used in rugged terrain, which is excellent for the greenfield exploration of sulfides. Adrok have experimented on many datasets from mineral exploration projects over the past 10 to 15 years in order to determine which statistical parameters of the ADR signal have the strongest correlation to sulfides at depth. The data here is broken down into 8 harmonic parameters from 2 groups, energy data in red and frequency data in blue. There is a lot of variability in these harmonic datasets, and we wanted to look more into this variability in correlation with sulfides. Adrok have established a set of sulfide correlation criteria from these harmonics, for example high energy mean, and has selected the top 4 peaks or troughs for each set of criteria to be given weighted values. The highest peak or trough is assigned a value of 4, the second highest a value of 3, third highest a value of 2, and fourth highest a value of 1. Once the values are assigned, we also assign a depth of influence to each of the top 4 peaks or troughs. The highest peak is assigned a depth of influence of plus or minus 20 meters, then plus or minus 15 meters, 10 meters, and 5 meters. Each selected point has a depth of influence associated with it, as well as a value. The results for each of the 8 sulfide correlation criteria are then compiled into stacked bar charts, with the different colours representing different harmonic results. We produce an 8-component WSCC chart as well as a 3-component WSCC chart, which selects the 3 most effective sulfide correlation criteria and tends to give similar results. Set baselines for sulfide interpretation are then assigned to the outputs, with a baseline of 10 in the 8-component and 5 in the 3-component. When comparing with drilling data, the results have proven to be outstanding. Adrok have tested the WSCC tool on over 15 different mineral exploration projects across the globe, from the hot Australian outback to the cold Alaskan tundra. This map shows the locations where the pre-drilling WSCC tool has demonstrated a capacity to delineate points of high potential for sulfide mineralization beneath the Earth's surface. As we dive into an Australian case study, we can see that a strong WSCC target between 600 to 700 meters depth correlates perfectly with the highest sulfide grade from drilling results that were given to us by the client. Here is another case study from Australia, where the client provided us with pyrite and sphalerite grade in a drill core down to 500 meters depth. Again, in this case, both the 8-component and 3-component charts produced WSCC targets above the respective baselines between 300 to 400 meters depth, which correlates directly to the highest sulfide grades. As we move up into the northern hemisphere, we can see a case study in Alaska, where the client provided us with drilling results for lead and zinc grades. Here we can see that this correlates perfectly with a WSCC target in the 3-component chart between 630 to 740 meters depth, but not in the 8-component, which is why we look at both outputs, as the 3 components have proven to give more accuracy on some occasions. The final case study is in Ireland, where the WSCC results are compared against a sketched cross-section built from drilling data that was not made available to us. In this case, the strongest WSCC target correlates to the occurrence of a black matrix breccia between 440 to 520 meters depth, which were known to host high sulfide grades. As well as being highly efficient in the exploration of natural resources, Adrok are also very conscious and responsible with our carbon footprint and emissions. An Adrok survey is environmentally friendly, with low power, non-destructive penetration and minimal impact to the local environment, with only our shoe prints left behind. A typical Adrok survey generates a relatively small carbon footprint of 4.72 tonnes of carbon dioxide equivalent, with the majority of emissions coming from the flight travel around the planet, and we always try to offset these emissions in other areas of the carbon chain. In summary, Adrok has developed a new mineral exploration tool called the Weighted Sulphide Correlation Criteria that can accurately locate and constrain sulfide deposits beneath the Earth's surface with minimal environmental